A trig identity is a statement that relates trig ratios and is true for all values of the variable. So we have already learnt some basic trig identities. These are tools that we already know. You know that cosecant is 1 over sine. You know that secant's 1 over cos, and cotangent is 1 over tan. I would like you to add to these, if cosecant is 1 over sine, does it make sense that sine is 1 over cosecant? And that cos is 1 over secant, and that tan is 1 over cotangent. Can you see that you could rearrange those so those are all true as well? And then we've also learned one of our big ideas, that tan was sine over cos. So if tan is sine over cos, then cotangent is cos over sine. These are identities you have already learned. Now, anything that you can do in one step in your head is allowed. So for example, can you see that if you multiplied both sides of this equation by sine, that cosecant times sine is equal to 1? So if you had cosecant times sine anywhere, you could change it to 1. No problem. Same thing with secant and cosecant. Secant and cos. And same thing with cotangent and tan. But for the most part, you're going to use these basic ideas as our start. So what we're going to use these basic ideas is for the next main thing that we're going to look at is proving trig identities. If you get a statement between one trig function and another trig function, and you get a question that says, prove the following, and I'll give you an example. Prove that secant theta divided by cosecant theta is equal to tan of theta. So we have some rules about proofs that we're going to do. If you get this question, prove the following, in your notes, you're going to rewrite what you want to prove and draw a line down the middle where the equal sign is. Because you don't know if this is true or not yet. It's your job to prove that they're true. And the only way that you can prove that they're true is by manipulating both the left side and the right side until they're the same. It's kind of like a puzzle.
We're going to be given false.
No, they will give you always, if they say prove that, it will work. So we have to go to our list that we just had there. Here's our list of things that we know. And with the things that you know, those are allowed in your toolbox for a proof. Okay? So there is going to be a common list of things that you're allowed to know. All of the reciprocal ones you're allowed to know. You're allowed to know that tan is sine over cos and cos is cotangent's cos over sine. We're going to add more things to it that we're allowed to use. And then our job is to solve this puzzle. So for example, what could I change secant to? I could change secant to 1 over cos. Draw a longer line because that's my main line. What could I change cosecant to? 1 over sine. So it's going to become really important that the basic identities, like what's cosecant, what's secant, what's tangent, what they're equal to, you have very well known so you can switch things quickly. Now I have a fraction divided by a fraction. So this idea that started at the beginning of this unit is going to come up lots in here. How do I do a fraction divided by a fraction? Multiply by the reciprocal. So one of the things that you're going to notice when you're doing these, just for causing you to have less errors, put a little space before you write your next thing. Because otherwise, it could all start to blend together and you might forget what's part of the question. So I'm going to leave a little space, and then I'm going to write multiply by the reciprocal. So I have 1 over cos theta multiplied by sine theta over 1. How do I multiply fractions? Multiply the tops, multiply the bottoms, and now I have sine theta over cos theta. So I changed it to sine and cos, and I now have sine theta over cos theta. Let's scroll up. Let's see what the whole thing is. Zoom, entire page. Okay. So we did all of that to change that to sine and cos theta. Can I change tan to sine and cos theta? What is tan equal to? So I could change this side that tan is equal to sine over cos. And we've solved the puzzle. Once you make both sides identical, your puzzle is done.
Do we have to convert both sides?
You don't have to. Some people would, instead of writing this, change this one to tan. Okay? In some cultures, you're only allowed to work on one side and not the other. Okay? But for us, it's fine. Because for those cultures that weren't allowed to work on one side or the other, they did work on both sides, and then just went down until they're the same and went backwards up until they got to the other one and rewrote it just so it was on one side. And just took longer because you had to write it out twice. So they're like, okay, it's okay if you change both sides as long as you never move something from one side to the other. Okay? Because the only way you can move something from one side to the other is if in fact they are equal. And you're trying to prove something is equal, and it is illegal to assume something's equal to prove something's equal. Does that make sense? Why that would be illegal? You can't move from one side or the other. That's why we draw the line. The line says both sides are separate, and if we can show that both sides are the same, then we can now say this is equal to this. Okay? Now, it's a proof, so there's some formalities where you've talked about. You have to do the line, work only on one side or only on the other side separately until they're the same, like solving a puzzle. Then once you've proven that they're the same, there's a statement you need to make. There we go. We go. Does anyone know what this symbol means? There are 3 dots. Does anyone know what this? I'm just kidding. Yes, it does mean therefore. Not there. There's 3 dots, and you say therefore. Wonderful. Okay? Therefore, the left side equals the right side. So we make a statement to say that our left side is equal to the right side. And then we can add some Latin abbreviations that you were hoping for. Okay? A lot of mathematical proofs. And with QED, I'm going to butcher some Latin here. Not even know if it's even close to if it's right. This stands for quod erat demonstratum, which is loosely translated, what has been asked for has been demonstrated or has been shown. So you asked me to prove this, I did. I'm feeling good. Okay, so this is the statement, the left side's equal to the right side. Now you're all feeling happy, so using some Latin like you're all really amazing. Okay, and then I like to end my proofs with a little square box that I shade fancy. There we go. Because you'll see in some textbooks when they're finished a proof, they have a little symbol at the end to say that it's done. You'll see in some magazine articles that when they're finished the magazine article, they have a symbol for their magazine that they put at the end. Part of the reason they do that is, I don't know if you've looked in a magazine, your article starts on page 1, it ends on page 7, and you have 135 ads in between. So it's like, oh, I read a paragraph, add. So continue on this page, read a paragraph, add. And you keep going and you keep going, and then finally you get to that little part where it is finished.
So do we have to write?
So you can make your own symbol up if you want. You're gonna have to write left side equals right side. I'm gonna ask you to QED if you want to add the little square, you can. If you want to make your own little symbol at the end, you can. I'll always put the little square.
But we have to put left side equals right side equals.
QED, yes. Okay? The first hint that you have for proving trig identities, for figuring out these puzzles, is if you look at every single identity that you know so far, reciprocal identities, quotient identities, if you pick any trig function, can you see that you're always able to change that to either sine or cosine? For example, pick tan. What can I change tan to? Well, I can change tan to 1 over cotangent, but I also can change tan to sine over cos. I can change cotangent to cos over sine, secant to 1 over cos, cosecant to 1 over sine. If you change both sides to cos and sine, and you get both sides to be a single fraction, there's a good chance that they're going to equal in the end. So that is your first strategy hint for these. Okay? It's not always going to be the fastest way to prove something. So sometimes you might go, oh, I have a really long proof. Did anyone find a shorter one? There's often more than one way to do it. But you have to get your left side equal to the right side. Can you see that we used the sine and cos strategy in our first one? I changed everything on the left side to sine and cos, and I changed everything on the right side to sine and cos. I got both sides to be a single fraction, and when I did, they were both sine over cos, so I was done my proof. So for each of these on your worksheet, you're going to rewrite the question. Draw the line where the equal sign is. Change things to sine and cos. Simplify your fractions. And see if you can get the left side equal to the right side.